So, hi, I'm Nicole. I'm really interested in the value/object model of C++, because I'm kind of a strange human being. Today I'm going to talk about that, and hopefully I will kind of understand the terrible, awful nature of the value and object model of C++, but also what's so friggin' wonderful about it. I'm sorry for the change in title. I did originally intend to talk about lifetimes. I'm not going to talk about that today. If you want lifetimes, go learn Rust. So a little bit about me. I'm a barista. I work at Starbucks, and most of what I've learned is by reading and reasoning about the standard. I'm really interested in object models in all of the languages all of the systems languages like Rust, C, C++, and how they differ and how they are the same. I am a barista, and I'm so proud of this. Like, holy shit, that's freaking awesome. I love coffee, and especially espresso. If you talk to me, I will talk to you for like 15 to 30 minutes about espresso machines. If you're into that, they're really pretty. Definitely recommend. And I've been programming since I was 8 in C. I got like a game programming book, and I learned Rust when I was 16, and that's kind of what started rolling downhill into C++. So, first of all, the rules. I want you to ask questions. This is not going to be easy for many of you who've kind of built up your own mental model of C++ over the years. So just raise your hand. I will call on you, ask your question, and I'll repeat it and try and answer it. And second of all, no corrections, please. There's going to be some stuff that's like not exactly right or like simplified slightly. This is intended to be like easier to understand than normal. And just give me the space to do this, please. The basics. What's a value? So if you think about it, like, what is a value? A value is kind of the Platonic ideal of a value, right? Like, if you have an int, a value of an int is a number between negative 2 billion and positive 2 billion. If you have a char, it's a number that represents a character in your execution set. If you have a string, it's like a list of characters. And what's an object? An object is just a place where you can store a value, right? So if you have, like, on the stack a string, that's just 3 pointers that point to the value of the string. Let's talk a little bit about functions. So value semantics in C++ are super duper important. They're kind of what C++ was originally based on. And this is how you kind of get copy by default. So as I understand it, Bjarne didn't really want like reference parameters, or not reference parameters. He didn't want call by reference by default. He wanted you to be able to have a list of strings in your main function, pass it to foo, and you know that foo doesn't mutate it. Foo gets its own copy of this list of strings. And it was like really different from other languages at the time. The other languages at the time were like Pascal and Fortran. They all passed by reference. Or you just had C, which passed by pointer because there was no copy semantics. And even when it did get copy semantics, there weren't any like copy constructors. So it just copied the bytes. And this was like a really important change from other languages. And I don't know of any other languages besides like D and Rust that have really started to use value semantics in this way. Did I do that twice? Reference semantics. But C++ didn't want you to just be able to use pointers, didn't want you to just be able to use values. You have to allow someone in a function that you're calling to mutate you, or to mutate your data. And it's the same call syntax, but you just add a little ampersand. And then you're literally talking about the exact same object, which is really powerful. And it works with user-defined types. It works with default types. Like, it works everywhere. I feel like there was something else I wanted to say about this. Oh, but like, you're basically passing the object. You are passing like a handle to the object. And if you look at it, like list here, that is the exact same type as list of strings. So let me think how to word this. If you think about it, like on the stack, you have a vector string there. And when you type vector string list equals whatever, you're saying, I want to create a vector string with the contents of whatever, and I'm going to say list is a name for that vector string. Like, list is not the vector string itself. And if you do like decal type list, it's not a vector string. It's a vector string L value. So the interesting thing here is like list of strings is exactly the same as list, which is a really powerful idea. Now pointers. Pointers are an interesting case. One of the things that people think about pointers is like, oh, they're nullable references, or oh, they're references that you can do pointer arithmetic on. But not really. Like, those aren't fundamentally what a pointer is. A pointer is taking a reference, putting it into the value system. So you're making a reference into a value. And this other nullability and arithmetic are just mostly cruft taken from C. Like, you can have non-nullable pointer types, and you just do optional pointer in order to get a nullable pointer type. This is entirely reasonable, and it's like what Rust does, right? And so one of the things you really have to understand is that a reference is not a non-nullable, no-pointer arithmetic pointer. It is actually like its own separate thing. It's not a funny pointer. It is the actual L value, the actual object itself, and then a pointer is just how you take that reference and make it into a value that you can make a vector of, for example. Now, let's talk about product types. So that's all easy, simple. We're getting into the real meat. What's a product type? It's not really common in C++ to talk about product types. But you can think of them kind of like as a struct. Or like a std tuple, right? Like you just have the values of multiple types in the same type. And a value of a product type is represented by the values of each of its members. And that makes sense. Each type's value representation is included in the value representation of the product type. And now we need to talk about constant reference members, because they are terrible. This is getting into the terrible parts of the C++. It doesn't fit into our world. Like, we don't have like a concept of a const type. We just have values, and we have values that go together. What is const? Like you can't assign to const types. Like, what is happening here? They are strange. And let's think about this. If you think about the value of a product type, it has all of the values of the member types. Yeah. And if you have a value of the product type, it includes the const member, and you can't mutate the const member through that value type, right? Like, that makes sense? Cool. I know I'm going fast. Like, I'm nervous, and I'm going fast because of it. So, what about assignment? Like, if you think about assignment, what is it fundamentally? In C++, it's the call to operator equals. But really, what is it when you do assignment? Like, what do you think is happening when you do assignment? Besides, like, operator equals, like, conceptually, what do you do when you're doing assignment? Say again? Say it louder? Right, yeah. And what do you do with the value of the old object? Right, correct. So you copy the value of the right-hand side into the left-hand side, and you discard the value of the old object. And so the new value really doesn't have anything to do with the old value, right? Okay. Const and reference members break that completely. And this is just like, this is pointing out what assignment is. You can think of it conceptually as destroying the old value, putting a new value into its place, right? And so this is true, but const and reference members break that. Const, and why it's kind of bad. A type mentioned in basic.fundamental and basic.compound is a CV unqualified type. Each type, which is CV unqualified complete or incomplete object type, or as void, has 3 corresponding CV qualified versions of its type. A const qualified version, a volatile qualified version, and a const volatile qualified version. The type of an object includes the CV qualifiers specified in the decl specifier sec, declarator, type ID, or new type ID when the object is created. Okay, so the standard doesn't actually give const a meaning here. It just says that it exists. That's fine. Let's see if we can find somewhere else. A const object is an object of type const t or non-mutable subobject of such an object. Okay. Great. I still don't know what I can do with const or not const. What's the difference? Except that any class member declared mutable can be modified. Any attempt to modify a const object during its lifetime results in undefined behavior. Oh, well that makes sense, I guess. Apparently it's a kind of object. Okay, so you can have const objects, right? You can have like static const objects, which are like a string or something, or like string, literals. They are a const object. This all makes sense. But what about pointers to const? Because it turns out that you don't just have const objects, you have pointers to const. I'm going to do a little beat poetry because I like it and because Michael is awesome. A CV decomposition of a type T is a sequence of CVI and PI such that T is CV0, P0, CV1, P1, ... CVn-1, Pn-1, CVNU for any n greater than 0. Where each CVI is a set of CV qualifiers and each PI is a pointer to member of class Ci of type, array of Ni, or array of unknown bound of. If PI designates an array, the CV qualifiers CVI plus 1 on the element type are also taken as the CV qualifiers CVI of the array. Example, the type denoted by the type ID const int star star has 2 CV decompositions taking u as int and as pointer to constant. End example. The n tuple of CV qualifiers after the first one is the longest CV decomposition of T, that is CV1, CV2, ... CVN is called the CV qualification signature of T. It is really hard to speak to the standard, I have to say. I am impressed with Michael right now, Michael Case. A PR value of expression of type Ti can be converted to type T2 if the following conditions are satisfied, where CV1, CVJI denotes the CV qualifiers in the CV qualification signature of TJ, T1 and T2 are similar, which means they're basically the same object type. For every I greater than 0, if const is in CV 1i, then const is in CV2i, and similarly for volatile, if the CV1i and CV2i are different, then const is in every CV2i for 0 is less than k is less than I. And this is the stuff that I'm talking about. Like, this ridiculous wording is all because they put const on the object type. If you had it on the L value type, you would just say, oh, it's a subtype. Like, it's easy. But no, they had to put it on the object type. And that means, like, if you have const int star, it's a pointer to const int as opposed to, like, say, a const view of an int. And what they're doing is they are intending you to think of a constant star as a const view of an int, but they're wording it such that it actually works with constant star being a pointer to constant. And so this all means that you can pretend a pointer to an object is actually a pointer to a const object. It's basically standard allowed type punning. So this is insane, obviously. Let's ignore the complexity of the standard wording for a bit and try to see what they actually want to have happen here. Is they want to be able to use const views. Like, that seems like an entirely reasonable thing to do. So back to product types. The standard cares about const objects. It also cares about const subobjects. This sucks. We can't define our own operator equals how we'd expect them to be defined. When you have a const subobject, you can't update it without it probably being undefined behavior. This is why stdlaunder was introduced, if you're curious. Basically, how it works is if you have an L value referring to an object, and that object has any const or reference members, compilers are allowed to optimize as if those constant reference members didn't change, even if you created a new object in that place. And this is a consequence of people who are obsessed with objects. Or really, it's like an old kind of thing where like C++ is really object-oriented. This, obviously. And so it has these issues. This kind of turned into a rant. I'm sorry. I get annoyed about this stuff because it's like really silly. Like, why does this exist? So what if const has these issues, what about reference members? And why they're cool, but also bad. What's the deal? The standard pretty much pretends that they don't exist. There is no standard behavior with regard to them. The standard only allows implementations to assume they don't get rebound. This behavior, as you'll see, is not great. They're basically like pointer members, but they don't get rebound. And does anyone not know what rebound means? Cool. So rebinding a reference is like changing what it points to, basically. So if you have like, it's like changing the value of a pointer, right? And how they work is in a product type. How a reference works is that it actually it points to something. It's a pointer, basically. And the value owns an alias. Like, you can think of it as owning an alias, but it's really the object that owns the alias. And it means that if you change the value, you can't rebind any reference members during that change. And it completely breaks the idea that this code is equivalent. Modulo exceptions. I didn't want to write that. And that kind of sucks. Like, I want these to be equivalent. I want to be able to write easy operator equals. But they're not equivalent. So how do we fix that? We pretend that the wording doesn't exist. Just ignore that part of the standard. And just never use reference or const members. This is kind of an unfortunate thing because I want to be able to say my thing will never change while I'm the same value, right? That seems like a reasonable thing. You have auto const almost everywhere. People do that. But then we could fix the standard to make structs rebindable and constant structs mutable. There are apparently people working on this. I should have worded that differently. What I meant is if you create a new value in that object, it should create a new value in that object. And not kind of create a new value, but pointers to the old objects don't point to the new object. So given this mental model, let's look at people's favorite data structure. Optional tref. Why it makes sense and has one sane way of working. The thing about optional tand is apparently some committee members thought that it was like a good idea to like, if it's some, assign to the reference, or assign to like the underlying reference, and if it's none, to rebind, which is weird. So let's put it into our model. Optional t is an optional value, right? If you have a function that takes an optional t, it's taking an optional value. Optional tand is a value that includes an optional reference. You can think of it as optional objects, but and same as with the reference members of struct types, assigning a new value to the optional should, actually assign a new value. Rebind semantics are the only ones that make any sense. Anyone have any objections to that? Because I'm actually curious, like, are there any objections to that? Okay. And then in C++17, we got real PR values. Oh, yeah.
I actually fully agree that the rebind semantics are the only ones that make sense. I'm just interested in knowing, do you have any thoughts on the same issue, but for tuple? Or maybe
for tuple, yeah.
Because like people really like their std tie.
So there are the opinions that I have, and then the opinions that actually make sense with the current wording of the standard. I do think that tuple operator equal should not do what it does currently. Like, I think it should rebind those references. That's what makes sense, right? But they're already in the standard. It's really weird that std tie returns a tuple of references. Like, why? Go ahead. Yeah. No, like, why does std tie return a tuple of references? They are conceptually distinct things. You clearly want to talk. Come up to the microphone.
I just want to say, so I wrote a library that handles tuples a lot, and one of the common features that people ask is, hey, you should support references in your tuples. And I know it's kind of convenient, but it just breaks the whole model. It just breaks everything. Everything breaks down. Nothing behaves as you think it should because, well, you're not rebinding. You're kind of assigning true to reference, and that just kills everything.
No, so I do think that tuples should support references, but they should support them under rebind semantics. Yeah, in general, I think that we could actually allow operator equal overloading to be done by the compiler. Like, there's no reason that operator equal needs to be manually user-defined. Like, it's just useless boilerplate at this point. If you write your constand constructor and your move constructor, just have the operator equal do that for you. Seems entirely reasonable. And then it would do the equivalent of the code from up, but with exception handling. Now I want to talk about C++17, because we finally got real PR values, and they're great. And stuff like this suddenly works. Before C++17, what happened was it would create a temporary, so here it would create a temporary object, and then it would copy construct on the equals for no reason. It just did, and like that's really. I think in older versions of C++, it actually like default constructed x and then operator equaled over. Thankfully, that was fixed at some point. But like, it's exactly equivalent to foo x. And like every compiler has supported this since the 90s. Like I literally checked. Every compiler has supported this optimization since the 90s. Borland C++ 3.0 supported this friggin' optimization, and then it just got fixed in C++17 because we actually have real values now. Turns out showing the error is kind of boring, or no error is kind of boring. But how initialization, if you're doing the assignment thing, like auto x equals y, got changed slightly. And so basically, if the initializer expression is a PR value, like a value that is not related to any object, and the CV unqualified version of the source type is the same You can read it. It's standardsy and wordy and terrible, but it's really good. It's called copy initialization. That's what it's called. So other interesting issues of PR values, I thought I might tell you how this works, because I find it interesting. So you have a foo that takes a string ref, and you call it with a string literal. What actually happens under the hood is we create an overload set for foo. There's only one overload, so we do that. And then we attempt to convert this crazy type into a string. Look at the conversions. We have like strings, like the copy constructor, the move constructor, all these weird constructors that I didn't know string had. Did you know a string has like 15, 16 constructors? Like, why does it need some? Anyways. So it sees, oh, look, string car const star. I can turn into that. I have, what's it called? Decay, thank you. So it has decay, and so it decays into the car const star. And then we call the string constructor. How do we turn that string PR value, like that thing, like that string that we get returned from the string constructor, into a string ref, like foo requests? Create a temporary. It's crazy. We like literally turn it into this. And like, that's great. I like it. I don't know. There was probably more of this at some point. I'm completely dead at this point. Const PR values. I feel like I needed to rant about this because I've been ranting about this all week, and they are dumb. What do you expect this to print? Seriously, what do you expect this to print? I'm curious. I want to like get audience feedback. What do you expect this to print?
What do we think it will print? Or
what do you think it will print? What do you think it will print? Okay. Copy, raise your hand. Nice. Move, raise your hand. All right. Second question. What do you think this is going to print? Copy. Move. All right, well, about half of you are wrong. You were the only one who was wrong right both times. No, you said copy the first time, didn't you? No, this prints move, because const PR values of int type do not exist. You did say move? Okay. Yes, so this prints move, because they literally just don't have, like they have a thing in the standard. Oh, and this prints copy. Because they have a section in the standard where they say, basically, we take PR values of type T, and if they're user-defined, we do nothing with them. And if they're standard-defined, we turn them into non-const PR values. I don't understand this. I actually do understand this completely, but I know exactly why they do it, and it's really silly. So changes that I would like to see in the standard. And I am so under time, and I know it, and I feel really terrible. But I have just a few. First, make constant reference parameters more normal. And I'm talking to the standards people in the room, and I'm like, you gotta do that. Because they are ridiculous. Like, they make no sense. Like, why would you want that? Why would you want those semantics? No compiler optimizes for it. Second of all, make const PR values not a thing. They are... And a rule that I must be given coffee as a matter of course during the meeting, because I think that's great. Yeah?
Just to clarify the second point, what you are asking is that even user-defined types basically go through this transformation where if they're a const t,
yes,
they're just a t, right?
Yeah.
Okay.
And that would be like,
Can you explain the I mean, it seems. Oh, it's a PR value, so you don't.
right. So there's no
notion of-
actual object. So this is like the one place in the standard where values are still objects. So for the longest time, you just kind of ignored values, and they were like, they're technically not objects, but they are objects. So you'll see this with like before C++17, copy initialization did that whole thing because it actually created a temporary object and then tried to move it over. And then there was like an optimization to turn that off, but like it required it. And so this is one of those last dregs of like values are technically objects because object-orientedness. It's like, despite there being like no other place in the standard where it's a const value, like whenever you read const in the standard, it's const object because that's what const is on, it's an object. But this one place in the standard is like, if you want to create a temporary of a PR value that's typed tconst, we'll make it a tconst object for some reason.
I see. Okay, and I don't want to throw a curveball at you, but could you maybe outline what you mean by more normal in the first bullet?
Oh, so more normal would just mean basically you could rebind them with, not rebind them. If you like put a new value into the existing object, you would just rebind them easily, or you would change the const value easily, and it wouldn't cause any undefined behavior.
Okay, so if I repeat that just to make sure I understand. And
Yeah.
I mean, you said you were under time anyway, and I think this might be useful for others. So
yeah.
What you're saying is basically, okay, if you have like reference or const members in an object and you kill that object, you destroy it,
yeah.
and then you build a new one on top, the standard should be worded such that the compiler sees that maybe the reference member was rebound,
yeah.
And the const object or the const whatever was changed. Is that correct?
Yes.
Okay, and so I think that would that way we would not need launder. Is that correct?
Say that again.
We would not need launder if we had
launder.
That.
No.
Is that correct?
No. Launder is, as you said, launder is useful for changing the vtable.
Ooh.
I don't know why you would do this, but you can actually technically change the dynamic type of an object.
But that's the compiler that does that. So this
no. Like you can like make a new object of this different dynamic type, but the same static type.
Okay. Thank you.
Yeah. Any other questions? I really am. This is my first talk, and I've screwed up the timing. But yeah, any questions? Go ahead.
So I agree that for optional tref, the rebound semantics are the only ones that make sense. For reference members, though,
yeah.
what I don't really follow is how reference members would be different from just a local variable reference that assigns through. Like, why are they different?
When you take the member as itself, like if you assign to the actual L value reference, it wouldn't be different. Okay? But if you assign to the containing struct a new value, like if you, let's see. Let us go to Vim. All right. So if you, beautiful. So if you have like a struct x and then an int and reference member, if you do x equals right, so that makes sense. If you do x dot ref equals 1, it assigns through.
Okay.
However, if you do x equals z, then it changes the binding of the reference.
I mean, that's not the behavior today, right?
It's not, no.
So you're saying that it should rebind in this case. And
Yeah.
I don't understand why it would, because
So,
it's more consistent to me to actually assign through in this case too.
Right, so,
So I don't really understand
the
why.
difference is, if you think of it in terms of values, like, so the value of the x
Yeah.
holds a reference to an int, right?
You mean the object Z?
No,
Object X?
So this value here
Holds reference to Y? Okay.
holds a reference to y,
Yeah, okay.
correct?
Uh-huh.
This is changing, this is assigning through the reference. However, this is changing the full value of the x. Like you are, the conceptual model is deleting the old value at that object and putting in a new value.
Okay.
It's going to help if you add this x here to make it
Yeah. Right? So you, okay. You know what? So this x is this value, and it's referencing y. This is taking the reference
Yeah.
y and assigning through it. This is a new x value that you're putting into the old object, right? So this is like, this no longer has any relation to this. You're literally assigning into an object and making it have a new value.
Okay, yeah, so I see what you're trying to say. What I don't quite agree with, I guess, is that X in this case with the reference member
Yeah.
no longer is an object that holds a value, right? Because we're holding references now. If it were an object that held values, then yes, when you assign to it, it should sever the relationship, get a new object with the new value, etc. But it's no longer an object that holds values anymore. So I'm not sure that generic applicability of assignment applies as soon as you inject a reference or constant member for that matter.
So my argument is basically that all structs are values.
But I mean, it's not, right?
Yeah, but like, so the struct,
I mean, it doesn't store
Sorry.
a value in this.
this
case, like-
itself is a value, right?
I mean, I think I already disagree there.
Yeah.
Okay.
But so that's basically my argument. Is like all product types are values. Like you have a value of a certain product type. The reference member doesn't change that. It's just saying that a value of this type
Okay.
has like or owns, in some sense of the word, it owns a reference.
Okay.
It is not a reference in and of itself.
But one more thing that I'll say
Yeah,
is
yeah.
that earlier in the presentation what I agree with is that you said reference types are not values, and then pointer is the reference types brought into the value system.
Yeah,
right?
yeah.
So based on that, I would say that a reference is not a value, and therefore a product type that stores a reference is not a value either. And so that's kind of where I disagree, I think, in terms of the
So
logic.
basically,
But I won't say anymore.
Yeah, just one last thing. Basically, in my opinion, a pointer should be able to be implemented as like this. Like, I don't see any difference between that and like a pointer that's non-nullable and you can't do pointer arithmetic on. Because it's bringing a reference into the value system by being a part of a struct.
Okay.
Yeah. Odin. I'm curious.
Really?
okay.
Because
sorry.
she's
go.
not looking at me. All right. As you said, a reference refers to an object, right? It's not
Yeah, yeah.
referring to a memory location, not a storage. So therefore, the notion of reference is tied to the lifetime of an object. And you said you wouldn't mention lifetime today, but I was wondering if you had, a short, not too complicated opinion about whether C++ right now could support lifetime qualified references. Are we missing anything before we could get this in C++?
A lot of annotations.
Yeah.
You could probably do it with Sal. I've been thinking about, I've got the visuals. Anyways, I've been thinking about doing this with like something like Sal. Like you could probably do, the Microsoft, you know the Microsoft things is like in like this really ugly thing that they have in the Microsoft C++ standard.
Okay.
Yeah. So you just basically have annotations like, so for example, I don't know, if you have a string view x, find, then this string view would have the lifetime of s, basically, right? Or like star s or something.
Yeah.
And I feel like you could probably do that in C++. You just have to write the tooling. And you have to write the annotations.
Okay, thank you.
Yeah.
So earlier in the talk, you said how when you declare a variable of reference type, you're not really saying I'm declaring a new object. You're saying I'm declaring a new name for some existing element.
Yeah.
On that basis that that references don't really have values in the usual sense, do you think it's even the right decision, if you could start again from scratch, do you think it's the right decision to allow reference members in class types at all?
I have like two competing ideas on that, like that fight each other in my mind. Okay. Anyways, so on the one hand, yeah, it doesn't really make a lot of sense to allow reference members. But on the other hand, I'm like, you know, what is a pointer other than just like a reference brought into the value system? And it makes sense to me to like make pointers and references basically the same thing. On the other hand, yeah, if you want to be like really, if you want to make a good language, you probably don't add reference members. Like if you want to make an easy to understand language, you probably don't add reference members.
So on the topic of going to the committee and trying to present these ideas,
Yeah.
we did, so when variant was being standardized, there was a whole bunch of talk about standardizing variants of references.
Yeah.
And just, there was maybe a 3,000 post thread internal for the standards committee regarding what the semantics would be of the variant of references. And I believe that there were 2 people who wanted these semantics, myself included, so I agree with you.
Yeah.
But we could use more people who think that way. But yeah, in addition to that, I completely agree with your statements about the structs.
Yeah.
But yeah, I just be warned that it's a tough battle. But on the top, I wanted to respond to Richard's comment.
Yeah.
And you backed away a little bit, but I want to defend this again though, that having them as members really is useful, and the main reason is they can come up as dependent types. So the main use case that we were fighting for with variant was if you have a variant of like the result types of a function call, you want that to be able to work. And if it happens to be a reference type, you don't want to be able to do you don't want to have to do metaprogramming, which you would have to do if you couldn't have a reference member.
Yeah, and I think like return values of reference type make a lot of sense. You know, and like parameters of reference type make a lot of sense. And like optional tref makes a lot of sense. Like you just want to be able to pass an optional object. You sometimes want to pass an object, sometimes don't. And I don't see, like the rebind semantics work, like really make sense in that case.
Anyway, I went off on a comment, but my actual question was, do you think that it is actually possible at this point to go and change what references mean in terms of structs? Because when I was doing it, it was only with respect to the library because I assumed that it was possible.
I think it's actually entirely possible because what C++ does is it says, we don't assume anything, right? Like, so first of all, you have the optimization that you just turn off, and it's already turned off in most compilers, if not all, apparently, that you can't rebind a reference, can't change const. So you turn that off, and then there's literally like the only difference is the implicitly generated operator equals. You might be able to have that in more cases. Even when you have like a user-defined copy constructor, move constructor, you could actually implicitly define move assignment, copy assignment, which is what I'm really want, because it's like a lot of boilerplate that's really silly.
I think I tend to agree. The one thing that I've encountered when arguing stuff like this as well is a lot of people really like the fact that they can create mutable or types that are immutable, and this is one way they do it is constant reference data members. I'm
just make it a wrapper or like do. C++ people. Yeah.
Okay. I have a question, but actually, I want to respond to the last thing you said about immutable objects. That was one of the first thoughts I had when you were talking about const members, was thinking back to a talk that I was watching online by one Kate Gregory, who is in the audience. And she was talking about reasons you would, like, when you would and would not want to have const objects rather than const pointers to objects, and that it's immutable if all the members are const. And I don't know. This seems to kind of conflict with the immutable objects. Is that, I don't know, but I guess then again, a immutable object would never be assigned into the same way, right? Or,
right, so the thing is, what I want is like Rust-style semantics. I hate saying it, but I do. It's like, you know, if the actual member is const, you can't assign to it. But like, you want values to just kind of work, and you want objects to just be kind of storage for values. At least in my world, I want objects to just be storage for values, right? And so you can mutate the things that are inside the value and like reassign things that are inside the value, or you can reassign the whole value and like, I don't know, it feels like const members might not be reassignable like by themselves, but you could, like they're just a value that you put over the old value, you know?
So what really scares me about this is that it makes me realize that I had assumed that these semantics were what I was operating on in my C++ code, and that because
this is
I would
why
like to think about these objects in the sense that I can construct an object. When I say it's const or it's a reference, I'm saying I'm going to bind this at the beginning of the lifetime and the constructor, and then when it's deconstructed, then it's gone, and the compiler will help me enforce that I'm not changing that in an inappropriate way.
Yeah.
But that I also had this assumption that clearly is invalid, that reassignment of that object was a change of lifetime event, essentially, which it seems to be not. So my real question is, line 28 doesn't do what I thought it would do. What does it do? Or does it not compile? Like,
it doesn't compile.
Okay.
Because operator equals is not like defined for things with reference data members. Yeah.
Okay, thank you.
Yeah. And yeah, it's really surprising. Like that's literally how I wrote my copy and move assignment operators for like the x dot blah x new and x z. That's literally how I wrote my assignment operators for the longest time, because I was like, oh, there's like no issues with const data members because I don't think about them. And it turns out that this is incorrect for a lot of things.
So if we had some way of some kind of operator dot, for example.
Yeah.
Because that's the problem with like reference. The main problem with reference wrapper is that you have to say dot get every time, and it's a real pain. But if we had a proper operator dot and a proper way of kind of delegating things to another object, do you think that we could actually fix this in the library by providing some kind of a rebindable reference type, so like a ref of t, that behaves the way we want it to? And then when you say, ref of t, dot something, it just goes to the underlying object.
I mean, but then you're like basically Rust. And you've got like pointers that have safety referencing, like you don't have to do the minus greater than. But then you don't have like the cool parts of references, you know? Like, and you
But I
can't
mean-
use the same thing everywhere.
Wouldn't that just give you rebindable references? Or
But
is there
the
something
thing is, I like don't want rebindable references. I want references that are part of other objects. Like the value can overwrite, right?
Sure. Yeah. Okay, that wouldn't fix that. Sorry.
Yeah, yeah.
Thanks.
Yeah. All right.
So, const PR values.
Yes.
This is a question which I asked in committee, and I don't remember who gave me this answer, but the story, as I heard it, is you have a function call that returns an object of built-in type. You try to assign to that, you get an error. Your life is good.
Right. Yes, that
You
is
have a
the
function
actual
call.
reason.
You have a function call that returns an object of class type. You try to assign to it, it compiles. Whoops.
You know how you fix this?
Well, I mean, at the time, you fixed this by making the return type const, but that's not the right fix. This was before we had reference qualification on member functions. Yeah, so this is the correct way of writing it today.
Yes.
But if you write it this
Everybody,
way-
start writing this.
If you
okay?
write it this way, you cannot
Please.
equals default it, which is bizarre.
What? Why?
Good question. Yeah. So I think, as I understand it, that was the reason why there are constant PR values of class types, and we
Yeah.
should just fix that.
Yeah, we should.
Also, I'd like to echo something that Matt said. Please come to committee meetings.
If you can pay for it, I'll totally come on my barista's salary. Or barista's wage. Yeah, wage. Any other questions? Cool. All right.